On this one, we're looking at what is the inverse of a function based on given set of coordinates. So we've talked about the inverse of a function already. We talked about number one, but let's talk about inverse again, since this is a different video. The inverse is when the domain and the range switch. So what happens is, in function 1, you have a domain and a range. For function 2, the inverse, the domain from function 1 is now the range for function 2, and the range for function 1 is now the domain for function 2. So when you have a set of coordinates and you're asked to find the domain or range, the inverse relation, apologize for that, the inverse relation, all you have to do is swap the domain and range, which is to basically swap the x and the y. So in order for us to write this inverse relation, instead of 2 being the domain and 1 being the range, they switch. So instead of 3, -4, I have -4, 3. Instead of 2, 12, I've got 12, 2. And instead of -5, 4, I've got 4, -5. And that is my inverse. All I've done is switch the domain and range, which is the x and y. So when you're given a set of points, a set of data, it's actually a lot easier to find the inverse relation than if you're given a function and asked to find the inverse relation, because with the function, you actually have to do some solving of the equation and some manipulating. Here, you've already got your domain and range laid out for you. All you have to do is flip them. So let's look at part B on number 2. So we're going to flip these. So this would be 10, 3. This would be 10, -3. This would be 12, 4. And this would be 12, -4. Again, we are switching the domain and range. That's it. And for this one, the 12, 12 becomes 12, 12. 18, 12 becomes 12, 18. We're switching the domain and range. We're switching the x's and y's. This becomes 12, 34. And this becomes 12, 1. So those are how you find your inverse relations based on giving a set of coordinates. Now, I am going to put this in the same video because we're still talking about inverse functions. In the previous video, we did write an equation for the inverse relation, and we're going to do it again, except this time now we're not going to be using squared terms. We're just going to be using linear or rational functions. These are actually linear functions. They're not rational functions. So we're actually going to find the inverse of this particular function. So the first thing we're going to do is we're going to write this as y equals. So that's become y equals x plus 2 over 3. Now, how do I proceed from here? Well, the first thing you want to do with your domain and range, remember, is to switch them. So I'm going to make this x equals y plus 2 divided by 3. And then I'm going to put x over 1. And the reason I'm going to put x over 1 is because now I'm going to cross multiply. I'm going to set up a ratio and make this a proportion. And there's two ways you can do it. If you wanted to, you can multiply both sides by 3. It's a reciprocal. You can do that. I'm going to do the cross multiplication. 1 times y plus 2 is y plus 2, and x times 3 is 3x. So in order for us to get y all by itself, my last step would be just to subtract the 2. So my inverse relation is y equals 3x minus 2. So this function is the inverse of this function. If you looked at the domain and range for this one, this is going to be the exact opposite. What's the domain here is the range here. What's the range here is the domain here. What's x here is y here. What's y here is x here. So let's look at the second example. Okay, so let's look at B. And B is 2x minus 3, f of x, equals 2x minus 3 divided by 3. So I want to find the inverse. I'm going to turn this into y. So y equals 2x minus 3 over 3. Then I'm going to switch my domain and range. So this is going to become x equals 2y minus 3 over 3. Once I've done that, I'm going to make this a proportion, put that over 1, cross multiply. So I've got 3 times x is 3x, and 1 times 2y minus 3 is 2y minus 3. Okay. So now I need to find y. So what I'm going to do is I'm going to continue on, and my next step is going to be to add the 3 to both sides. I want to get y by itself. So 3x plus 3 equals 2y. And then my last step is going to be to divide everything by 2. We've done this before. So this is 3 halves x plus 3 halves, which is 1.5, equals y. And that is your inverse relation. That is an inverse of that. So let's look at the last one. Let's look at the third one. The third one is f of x equals 12 times x plus 8 over 4. Okay, so the first thing we're going to do is we're going to change this to y equals 12 times x plus 8 over 4. And then we're going to switch the x and the y, the domain and range. So x equals 12 times y plus 8 over 4. Well, there's something nice that we can do here, something easy. The 12 and the 4 here reduce. So 12 divided by 4 is 3. So I can rewrite this as x equals 3 times y plus 8. Now I no longer have a fraction. So I'm going to distribute. So x equals 3 times y, which is 3y, and 3 times 8, which is 24. Remember your distributive property. Okay. Then I'm going to subtract the 24 because I want to get the y by itself. So I have x minus 24 equals 3y. And then for my last step, let me scoot this up a little bit, I'm going to divide everything by 3 because I want 1y. So I have 1/3 x, or x over 3, minus 8, that's what 24 divided by 3 is, equals y. And that is your inverse relation to this function.